All right.
Sorry, just a few seconds.
Yeah. Like the other phone, longer.
Well, I don't know if you need.
And then what do you have still have 5 on this?
Sign up.
Oh, yeah, and then yeah, just 2 5 and 5. Because you don't have a 10 anymore. Because negative
I don't know.
5. Okay, so ready or not, I want to hear what you got. Sine of alpha plus beta. Shiv, what'd you get? So I got sine alpha cosine beta plus sine beta cosine alpha. Oh, I'm frozen, aren't I? Thank you. And sorry, after cosine beta, you said cosine, sine beta cosine alpha. Sine beta cosine alpha. Plus minus for.
Okay, so this is for plus, and we're not gonna make the whole other one for minus, right? So minus goes here, and then minus here. Are we good with those? Yes. Thank you, Shiv.
I appreciate your help. Oh, help me out with others, please.
Okay.
So let's do cosine. Let's start with just plus, if you don't mind. Okay,
Right.
I don't know.
Minus. Okay, so minus. Okay. Are we good?
Yeah. Wait, this is not. No, it's cosine minus 9.
Oh, cosines come first? Is this
Yeah.
true?
Yeah.
Are we sure?
Cosine, yeah.
You want to take a look?
I think it's cosine.
It starts with the cosines. Yeah, I think it starts with cosine. So you're correct. The sign is opposite.
And also, I think, and that's
So
A.
cosine alpha, cosine beta. Are you seeing it? So cosine alpha, cosine beta.
Wait, no, it's
Sine.
Oh, I'm sorry. It's not. That'd be 0. Sine alpha. Bless you. Sine beta. Okay, so we have that, and of course, if we wanted to have subtraction, then we do the same thing, except you would add.
I like.
We're good.
You like? Yeah.
You like the?
I like the inverted.
Yeah, it's kind of fun. Like we haven't seen that before. It's kind of a new thing, and it has meaning, which I like also. Thank you.
My generate.
Okay, number 2. Can't ask. I'd like to. No present. She is here, right? For all of us, right?
Yes.
Okay. Right here in the flesh. I don't know a sine of 20. How am I supposed to do this problem?
So this changes to it's sine of 20 degrees plus 10 degrees. So it's sine of 30 degrees or sine of 5 or 6. It's a good one.
Ooh, going into radians. Okay. And that's 1/2. You sure about that? Are we good? Thank you. Do we need to change the radians?
I just like to think
No.
about it because I think the unit circle.
Yeah. Yeah, so it's kind of optional. But I think that from what I saw on the last quiz, students are generally very comfortable with radians, which is great. I'm glad that you've been able to make that switch, especially on the standard place along your circle. I don't feel like you're locked to them, so remember degrees or radians or either one is acceptable. No, that was great. Thank you very much. Jonas, you have a question?
Can I do B?
Yeah, help me out with B here. I'd appreciate it.
So, with B, you want to kind of set up the formulas for a sine of
beta, you want to say sine of alpha plus beta is equal to sine of alpha plus times cosine of beta plus cosine of alpha.
It's plus?
It is plus.
Okay. Plus cosine of alpha and sine of beta?
Yeah.
Okay.
And then for each of the ones, kind of think of it as a triangle.
Okay.
With the kind of the range applied. So sine of you can actually substitute all these values. Sine of alpha would be 4/5.
Would be 4/5.
It says.
Oh, I see. So here we could put 4/5. Is that what you're saying?
Yeah, and then if
Okay.
you solve for cosine of beta by using like a triangle and Pythagorean theorem, you can get -1/5. Then part 3.
Okay, so what you're saying is you could do some work over here and you have a triangle that is where?
Part 3
For alpha?
for beta.
Okay. Okay, we gotta find cosine of beta. So quadrant 3. And you knew to quadrant 3 because
3/5.
I hope they are getting meaning from this. It's not just random stuff written on the board that says the angles in third quadrant. Okay, and help me
And
from there.
you can plug in since we know that sine is the opposite over hypotenuse. You can plug in those two values, use the fact that you're find the third one, and then you can plug it into
Like that?
yeah, and then you can
Okay, did you get that already?
came out to -1.
Are we okay with that, everyone? Okay, and how does that help?
And so you can plug it into the equation as the c of the answer to cosine of b of -1/√5.
1/5.
And then you can do the same thing for alpha. Draw a triangle. It ends up being a 3/4/5 triangle, except it's negative 3/5 for cosine of alpha.
And this is in which quadrant?
2.
Okay. What's wrong? It's a triangle. Doesn't count. What's wrong with that?
Wait, it can't go.
No, can't do
Data
that.
is square in a standard.
It needs to be standard position, so initial side is here, and the other side has to be not like detached from that. It has to be there, somewhere in that sector. So hopefully that made you very uncomfortable to see that triangle. And I'm sorry for that, but it was necessary. It's part of growing. Okay, so I have our triangle. Oops. Yeah, it's always to the x-axis. Okay, from there.
You can plug in the values. Y is 4, and the hypotenuse is 5. And that's 3/5 triangle, but that's in quadrant 2 would be -3. And so you can just use that as sine of alpha -3/5. And since we already have sine of alpha or that, and then multiply it together.
Sine of
Beta is 2.
2/5. Are all these pieces making sense?
Making sense.
Oh, good. And then was this difficult to finish?
No, this is
Good.
they have the same denominator.
That's the answer.
I got 2/5 at the vacation.
2/5/5?
Yeah.
Is that acceptable as an answer in this class?
Kind of.
I would say it is.
Or do we rationalize it?
It's perfectly acceptable.
Okay.
Perfect. It's fine. You never need to rationalize mathematically in this class. If you did, that's great, and you would get. What would you get?
A thumbs up.
And smiley face.
Smiley face. Mathematically, you would get 2√5/25, and then just cancel the 2's or something like that.
Yeah, I like. Yeah, that's for
Yeah. Just gotta finish it up right like that. Okay. Shall we continue? Okay, we're gonna do a couple practice problems. We're gonna make an extension into some new territory. And we're not gonna be using our notes today. So you're gonna need some like fresh sheet of paper or just continue on last time's notes. Go ahead and get ready for that. I need to make a new paper stuff here. Boy. Scratch paper. Let's start with figuring out the cosine of pi over 12. I'm gonna take a moment and think with your neighbor, how do you do this problem?
That's not one. Well, it's kind of 60 minus 6 for it would be.
Oh, I was, yeah.
So, wait, here's how you do it. It's cosine of pi over 6. Cosine.
I would take it out.
So it's root 3 over 2.
Oh, you don't get
one. You have to do it.
Yeah.
So it's.
I see things.
Switch times.
Maybe for you.
Yeah. Multiply it to the, but what's the difference? What's not?
How do we solve this?
Oh, well, it's also.
Are you getting something?
Alright, 2 minus root 3.
What are you supposed to do with this?
Expand.
Expand to what? Say that again.
Don't
Cosine.
ask me, I don't.
Okay. Oh, yeah, I did.
I do. I have it.
Okay. Oh, okay.
That X value that I have. 5 or 6 is.
Okay, actually, let me catch up to you. So for this one, this is if you're on a unit circle, and this is root 3 over 2. Is that what you're saying? Okay, and then half of that, pi over 12. Okay.
No, because if I have something like this.
Oh, what is that?
The angle in that.
Okay.
And so then I got this, and now I'm realizing that I keep on.
I think you're right up to here.
Well, yes, I think I'm wrong.
Uh,
Steps, because I think I would got like for the sign value, it was wrong now.
Mhm.
That angle, both sides are like slightly. So that would be like 1/4, but I don't know. Now I don't know. Oh,
I see. So
the Y value, then you can.
well, that's a good question. If like we know the X value, this isn't a really easy one to cut in half. Would this be 1/4? Would it be half of that? If you cut the angle on that,
So it's circle.
yeah. The problem is that we are in a circle here, so it's not like a linear thing. So, but you're right. If it were like kind of more predictable, then we could do something like that.
No.
Let's compare it to what we see. Coming up. Yeah, some other ideas. Yes.
I have a theory to put to the test.
Oh,
So I remember one time I was in math lab and I was trying to figure out how to do this one problem. Like this type of thing, finding
Okay.
out the distance between like the halves.
okay.
So what you have to do is you get their x values. So the x value, or so
X value.
you need to find like the 2 points on the unit circle that pi over 12 is between. So
Okay.
pi over 6 and 0, which a cosine like of 1.
So this is, I think that what you're doing is you're going here, and this aligns perfectly with what Bella was saying.
Yeah.
So let's see if we piggyback on that. Okay, so you're here.
Yeah, and you're in between pi over 6 and 0, or like 2
Okay.
pi. And what you're doing is you're comparing, like you're taking the x value, so it's pi over, or it's root 3 over 2,
Mhm.
and for 0 it's 1. Then you're like subtract them from one another and then multiply it by like 2/3 or 1/3. I forgot exactly why, but
Okay.
little hypothesis.
Interesting. Okay, we have a hypothesis.
Yeah.
So along the same lines. Nia, do you have an idea? Okay. Okay.
Some.
Okay.
Was sine, I used pi on before.
Is this true that this is equal to pi over 12? Oh. Is it true that this is equal to pi over 12? I think we can verify this pretty quickly. So you're saying use the tools that we have in class maybe to do this problem. Okay.
Well, we already know cosines and sine of that,
Okay.
or, pi over one.
Yeah, these are standard place on your circles. So now we could use the formula like you were talking about. Do we start with cosines or sines for this? So it's going to be cosine of pi over 4 times cosine of pi over 6. And that's going to be, is it plus? Are we sure?
Yes. Sine pi over 6, or sine pi over.
Sine pi over 4, sine pi over 6. And Nia, can you tell us what you got in the end, please? Over 4? Yeah, okay. Did anyone else get this? So you can copy it off. Yeah.
Okay, let's see what I got. 30 or not 30.
Are you getting it?
Oh, I got it.
Is it okay to have square root of 6 plus square root of 2? Yeah, that's fine.
Got that.
Yeah, looks great. Thank you. Any questions?
Anything actually?
Yeah, this is what I'm looking for.
The one.
Yeah, this is what I'm looking for. The question is, how could you come up with a pi over 4 and pi over 6? So I'm going to give you two different ways of looking at it. Since this is a pretty small angle, I hope it makes sense. We're going to use subtraction to get there.
Yes.
So the question is, what minus what equals pi over 12?
Oh.
And we know that it's going to be pi's on top. So it could be like 2 and 1.
That one. Well,
That would work, except
you end up.
You need to know what pi over 12.
yeah, we need to know what pi over 12 is. Defeats the purpose. So instead of 2 and 1, we could do maybe 3 and 2. Would those be? Or maybe 4 and 3? Right, because we know both of them. We know everything about those two angles that combine to be pi over 12.
So, anyway, that you did, we get the same.
Yeah, we get the same answer. But I do want to show you another interesting way to do this. Directly from the unit circle. So let me see if I could share this view here. Do you all see an angle that is pi over 12 radians here?
Yeah.
I'm not talking about the invisible one. I'm talking about, yeah, there's, how many pi over 12 angles do you see? How many?
Oh, I see it.
They're not in standard position, but they're pi over 12 angles. Specifically, and let's see if I can write on here. Isn't this pi over 12?
Yes. Yes.
So how can we get that measure?
You knew. Oh, you can take cosine.
No need for cosine.
Sure.
We know. Yeah, this is pi over 4, isn't it?
Minus pi over.
And this is pi over 6. So you can start with that pi over 4 and then close up by subtracting pi over 6. So pi over 4 minus pi over 6. Or, since this one is what is this pi over 3, you could say pi over 3 minus pi over 4.
What about pi over 3 minus pi over 6 divided by 2?
Interesting.
That,
I think we have a division thing, so.
oh, yeah.
Yeah. Or we could use this, can't we? Right there. That'd be what? We start with the big one. 5 pi over 6. Isn't that 5 pi over 6? And then subtract 3 pi over 4. There's pi over 12 everywhere, but it's just it's up to you to figure out how to get it. Or I think I already change it to degrees. And from there, it's a little bit more. There's a little bit more flexibility. which would be possibly perfectly fine. I think it works out to be the same, just you're in degree land. And degree land is a fun place to be, but you don't have to be there. You could be there. You have degree mode in your brain. Degree mode. Okay.
Could you go back to that, how you were doing it?
Yeah.
How you go 4, 5, 6 to root 2 plus root 6 and
For sure. Cosine of pi over 4 we know is
Root 2 over 2. Cosine of pi over 6.
so
Multiplying that, etc. I'm just going to finish up for completion's sake. And this is 1/2.
Are we good? Ready for another?
Yes.
Have another?
You're ready for.
Just a minute, I had to look back at my notes. It looks like I'm not ready for another. I'm ready. I was hoping to be ready, but I think.
Maybe it's just.
Oh no, we're good. Yeah, I do have an extension from the notes.
Okay.
because
We're good. And then the quiz, yes. Yesterday we talked about angle sum and angle difference identities. Today we're going to be talking about double angle identities. Specifically, we'll start with sine of 2 alpha.
I thought this was gonna be part of the quiz, really.
No. So in other words, if we want to find, I don't know, sine of 60, we could base it off of sine of 30. We can do a double of some sort of angle. What we need is a formula here for those of you who don't already know. But as you do know, the definition of multiplication is that this is just sine of alpha. A definition of multiplication. Alpha plus alpha. And now we could use the identity we already know. Instead of alpha and beta, it's alpha and alpha. So can you finish this based on what you know?
he's like fun class. You thought I was he's a lot. It's fine.
Okay. Did you get it?
Yeah.
So it's sine alpha times cosine alpha plus cosine alpha times sine alpha.
Simplify it.
And these terms
Okay.
are the same. I'm actually going to make a list down here to put them together. Sine of 2 alpha is equal to 2 times sine alpha cosine alpha. That's just a relationship. Can you also do cosine of 2 alpha, please? Wow, that's equal to. Check with the neighbor once you got an answer.
Right. I feel like there's some like there's some trick here.
This stuff is trickier.
Yeah, trigonometry.
Yes.
A trig.
Okay, I'll see what you got. Jonas, did you have an expression for a cosine of 2 alpha?
Yes.
What you got?
Since you can say it as cosine of alpha plus alpha.
Let's
can say-
cut to the chase. What's the end?
Of the end thing, I got cosine of alpha, cosine squared of alpha minus sine squared of alpha.
Are we good with that, everybody?
And it comes directly from the angle sum identity for cosine.
That means cosine of alpha.
Oh, that's a good question. So is this equal to 1? It's confusing, isn't it? Like, where it's easily mistakable for 1. Exactly. Yeah, so please be very careful. When it's being subtracted, it's equal to cosine 2 alpha. When it's being added, it's equal to 1. With that in mind, let's use this. We know the cosine squared of alpha plus, sorry, sine squared of alpha plus cosine squared of alpha is equal to 1. If we say cosine squared of alpha is equal to 1 minus sine squared alpha, we're able to make a substitution into here, come up with another expression for this double angle formula. Do you see what I'm saying?
Oh, wait. 1 minus 2 sine squared.
So I'm gonna do my work on the side here. So here's my double angle for cosine. I'll substitute this in here. So I get 1 minus sine squared alpha minus sine squared alpha. Does that simplify? Yeah, 1 minus 2 sine squared alpha. So that is actually a second option for these formulas. And there is a third one. Do you see how we're going to get it?
Yes.
I'll give you a chance to work out what that third one is. So you're substituting in for sine squared alpha from the Pythagorean identity. And if you did it right, you get 2 cosine squared alpha minus 1.
Wow.
I recommend this being your home base if you're memorizing. And then the other ones you could produce from substitutions from Pythagorean identities. Let's see. Let's see. It's
No, like not in this problem. It doesn't.
cosine squared plus.
I'm not talking about the problem you said like for memorizing, I said like would you?
Oh. For a double angle, it's going to be minus because alpha plus alpha goes with minus. Okay, so one example, if sine of alpha is equal to 3/5 and alpha is between pi/2 and pi, find sine of 2 alpha and cosine of 2 alpha. Let's see what you can do with this. Please use the identities of today. Make sure your neighbor's doing okay with these.
Yeah, there. Yeah, I got one.
numbers you should get should give you a nice surprise. Like a happy little present. You see it?
Yes.
You should really like the numbers that you get.
Wait, did I do it or which one? Oh.
Oh, wait, oh, you're right.
I guess it's not a present.
You're right. Oh, it is like,
Yeah.
is this the present?
Oh.
That is a
I was-
present, isn't it?
Well, that actually, that's nice.
Did you draw alpha? And did you actually use X and Y axis when you do this? I recommend it. You don't have to.
Just to make sure that your positive negatives are taken care of. In this angle, this is actually alpha. 3 is here, 5 is here. We know the other side is -4. Okay, so for a sine of 2 alpha, we know that this is 2 sine alpha cosine alpha. So this is 2 times sine of alpha, we already know is 3/5. And cosine alpha is -4/5. Okay, so this all together, this equals -24/25, which are really nice numbers, aren't they? We recognize them from, Pythagorean triple triangle, 7, 24, 25. When you go to that cosine of 2 alpha, now remember there are 3 different formulas you could use. Would it make sense that in this case, especially if we just were asked that one, it'd make most sense to do the second one? Since we were given sine? If that's all it was asking, that it would make sense to just go right there. Yeah, I'll do that one just for fun. Just 1 minus 2 cosine squared alpha. So you have 1 minus 2 times, excuse me, 1 minus sine squared alpha. Sine is 3/5 squared. 1 minus 2 times 9/25. 1 minus 18/25. Should get you, no matter what you use here, you get that 7/25. So, and you see the gift is the full triangle there is there, that's 7, 24, 25. Yes.
So you also just get that, I'm just like, do 7, my order was, the sine was 24.
Right? Right, we already had from that angle, we had the opposite and the hypotenuse. So we knew that the adjacent would have to be 7. The question is it positive or is it negative? And since we don't know what quadrant is, you kind of have to go through the work, unfortunately, because otherwise you're just guessing positive 7/25. Yes, Nia. Is there any, what do you mean, is there any? Mhm. Right. How do you know it's in quadrant 4? Is it in quadrant 4? We now know, but we didn't know before.
The Y value.
Yes, the y value is negative, the x value is positive, which means we have to, this angle has to be in the 4th quadrant. Isn't it? Well, yeah, algebraically, we have an angle here between pi/2 and pi. So if I were to double all this, then we would get that this double angle is somewhere between pi and 2 pi. It's gonna be in the 3rd or 4th quadrant. So until now, it wasn't clear, but because we got that negative and positive, we got the 4th quadrant. If they both were negative, which might happen, then it would be in the 3rd quadrant. But that's not part of your analysis right now. This analysis section. We'll take the quiz, folks.
Oh, it's time.
It's time.
Oh,
Yes.
Nervous, you got this.